All right, this would be DNA transcription, a dry run. All right, so I'm going to draw our template strand of DNA like this. Just a bunch of lines. This would be our 3' end. This would be our 5' end. Okay, and all these are our bases, and our goal is to make mRNA. Right, and there's 3 stages. There's initiation stage, which is the beginning right here, and then the elongation stage, and then the termination stage. So first, in the initiation stage, we have RNA polymerase. But RNA polymerase needs somewhere to bind. Okay, so we have what's called a promoter region, and if our start codon is right here, that's our start codon. Our promoter region is usually starting 10 base pairs from the back of the start codon. So we'll just say like right here is -10, and then it continues back -35. So this right here is our promoter region. And usually promoter region consists of adenine and thymine, also known as the top box. Oops. So this is our promoter region. This is where RNA polymerase is going to come in and bind to this area. So we'll just use green. That's our RNA polymerase. Now, RNA polymerase isn't just going to turn on by itself. So we have what's called transcription factors, and they bind to the DNA down here. And they're going to wrap around, they're going to come up and they're going to wrap around the RNA polymerase and activate it. And then the RNA polymerase is going to shoot off in this direction. So the transcription factors are going to bind to the RNA polymerase, they're going to activate it, and it's going to shoot off. And then once it hits that start codon, it's going to start transcribing the DNA to make RNA. And once it starts with the start codon, it's going to go all the way to a stop codon. Also known as our terminator sequence. And this whole piece right here, from the start to the stop codon, that's what's going to be transcribed to make mRNA. So this is our initiation stage. Our elongation stage would be from the start to the stop codon. And then once it reaches the stop codon, the RNA is just going to break off. This will be our RNA, the red. So again, once we reach a stop codon, it's just going to break off. We're going to have messenger RNA. So we finished the termination stage. Now we have to prepare the mRNA to leave the nucleus and enter the cytoplasm. But first thing we need to do is we need to get rid of the junk that's in the mRNA. So we have what's called introns and exons. Intron, exon, intron, exon. So the introns contain junk information. So to get rid of that, a spliceosome is going to come in and it's going to create a hairpin like this. This is our hairpin, and this is going to be an intron. These are exons. So this would be like intron 2. This is exon 1, exon 2. So the spliceosome is going to come in, create this hairpin. The green is our spliceosome. And it's going to get rid of that intron. So then we'll just have intron 1, exon 1, exon 2, right? The spliceosome is going to come in and it's going to remove these introns, just getting rid of all that junk information that we don't need. So next thing we're going to do is we're going to talk about our 5' cap. And our 5' cap, obviously, is going to bind to the 5' end of the mRNA. We'll give the 5' cap a different color. Just give it a square. 5' cap. All right. And then on the back side, we'll have the poly A tail. And poly A tail obviously attaches to the 3', and it's just a bunch of adenine like this, right? So we have the 5' cap and the poly A tail to give mRNA pretty much access to leave the nucleus and enter the cytoplasm, because there's a lot of proteins that guard the nucleus, things coming and going. So the 5' cap, the poly A tail, sort of bypass those proteins so that we can enter the cytoplasm. And that is DNA transcription.